Alright, in this video we're going to look at angles in standard form. So an angle is in standard form if its vertex coincides with the origin and if its initial side coincides with the positive x-axis. So the angle is going to be oriented like this. This is your terminal side, and of course this is the initial side. If this point on the terminal side has coordinates xy, then it means this side is going to be x and this side is going to be equal to y, and our angle theta will be there. So that means an angle can be in the first quadrant if it's acute here, or it can be in the second quadrant, it can be in the third quadrant, it can be in the fourth quadrant. Now, by Pythagoras, the hypotenuse of this triangle, we're going to call it r. It's going to be the square root of x squared plus y squared. This number is always going to be a positive number, so it's always greater than or equal to 0. Now, so we can now define the trigonometric identity, the trigonometric ratios of theta. So sine theta, for instance, is going to be the opposite over the hypotenuse, so it's y over r. Then cosine theta is the adjacent over the hypotenuse. Then tangent theta is going to be the opposite over the adjacent. Then we're going to define trigonometric ratios which are reciprocals of sine, cosine, and tangent. The first one is cosecant. So cosecant theta, we're going to abbreviate CSC, is 1 over sine theta. So that one is going to be r over y. Then cosecant, or rather secant, secant theta, which we're going to abbreviate sec theta, is the reciprocal of cosine, so that one is going to be r over x. Then cotangent theta, which we're going to abbreviate cot theta, is 1 over tangent theta, so that one is going to be x over y. Now we're going to look at the signs of these trigonometric ratios and the various quadrants of the coordinate plane. So this is the first quadrant here. This is quadrant 2. This is quadrant 3 here. This is quadrant 4. The first quadrant, both x and y are positive. So that's in the first quadrant. X is positive, y is positive. In the second quadrant, x is negative, y is positive. In the third quadrant, both x and y are negative. In the fourth quadrant, x is positive and y is negative. Now remember that we said r is always positive. Okay, so that means in the first quadrant, this is going to be positive, that's going to be positive, and that's going to be positive. So in fact, in the first quadrant, all of these ratios are going to be positive. So we're going to write all positive there. So in the first quadrant, they are all positive. In the second quadrant, x is now negative. So that means this one is still going to be positive. This one is negative. This one is also going to be negative because x is negative even though it's positive. So in the second quadrant, only sign is going to be positive. Right, only sine theta is positive. In the third quadrant, both x and y are negative. So this is going to be negative. This is going to be negative. But this is going to be positive because we're going to be dividing a negative by a negative. So in this quadrant, only tangent theta is positive. And then in the fourth quadrant, y is negative, so it's negative. There's negative, only cosine is going to be positive. Only cosine theta is going to be positive. So this is going to be very important in what we're going to continue to do, remembering these designated signs of the angles in the different quadrants. Okay, the next thing we're going to talk about is what is called coterminal angles. So first of all, coterminal angles. What are coterminal angles? So these are angles that share the same coterminal side. So these are angles that share the same terminal side. So these are angles that have the terminal side in common. Let's do an example. Alright, let's take the angle 30 for instance. So if this is 30 degrees, then what are the coterminal angles of 30? Well, if you go round once and then only stop on the second go, then this is going to be 30 plus 360. So that's going to be 390. So that means 30 is going to be coterminal with 390. Or alternatively, instead of going counterclockwise, we could go clockwise. Now remember, we said angles in this direction are designated negative. So this time it is going to be 360 minus 30, but negative, so it's going to be negative 330. So again, we could go round once and then stop on the second go. But I think for now we're just going to work with these 3 coterminal angles here. So our interest is seeing whether what do they have in common. So we're going to have theta here, we're going to work out sine theta here, and cos theta for each of these angles. So we're going to have 30, 390, and negative 330. Okay, so let's see what the sine of each of these is going to give us. So sine of 30 is going to be sine of 30. Okay, that's 0.5. And then let's do sine of 390. Also 0.5. And then let's do sine of negative 330. So negative 330. It is also 0.5. Okay, then let's do the cosine. So cosine 30 is 0.87. And then I'm going to do this on a different line now. Let's do cosine 390 so that we can compare the 2 values. We can see that the 2 are exactly the same, this one and this one. So again 0.87. Then let's do cosine negative 330. Again is 0.87. Right, so we're going to make a conclusion now, and the conclusion is going to go coterminal angles have got equal trigonometric ratios. This is going to be very important. A bit later we're going to come back to it. Okay, and then there's something called the reference. Okay, the reference angle is the smallest angle made by the terminal side with the x-axis. So that means the reference angle is always going to be an acute angle. So let's just do some graphical demonstrations here. So if we have an angle in the second quadrant, you can see it makes 2 angles with the horizontal axis, this one and this one, and the smaller one is this one. So that means this is going to be the reference angle. Okay, same thing. Well, if we have an angle in the first quadrant, then the angle itself is going to be its reference. But if we've got an angle in the third quadrant, then remember that is the angle. Okay, and then in terms of smaller angles it makes with the horizontal axis, there is this angle here and there's this angle here, but the smaller one is going to be this one. Remember, we said this is always going to be acute. And then if we've got an angle in the fourth quadrant, then that is going to be the reference. So if we take that example of 30 degrees that we did before, this is 30 degrees, it's got reference 30. If we take 150 in the second quadrant, then this angle here is going to be 30. If you take 210, then again that is going to be 30. If you take 330, then that is going to be 30 again. So these four angles are going to all have the same reference angle. Okay, so I think, so let's see what happens with this one. I'm going to write theta, going to write ref theta here, then I'm going to work out sine theta. So sine theta, and I'm going to work out cosine theta. Alright, the ref theta should be actually not here, it should be here. So we have got ref theta here, and then we're going to have sine theta and cosine theta. So for 30, ref 30 is the same as itself. Sine theta, we've already found that it's 0.5. Cos theta is 0.87. Then now we're going to go to 150. So sine 150, 150 is equal to 2.5. Okay. Ref 150 is 30 because it's 180 minus 150. Then let's do cosine 150. It's negative 0.87. Okay. Then let's go to 210. The ref again is 30. So what is sine 210? It's negative 0.5. What is cosine 210? It's negative 0.87. Then let's go to 330. The ref again is 30. Sine 330 is negative 0.5. Cosine 330 is 0.87. Now, what do we notice? Well, we notice that all the sine values are 0.5. All that changes is the sign, and of course the sign changes, it obeys the rules of the signs of the trigonometric functions. So we know that sine is positive here, sine is positive here, but sine is negative here. So that's why in the third quadrant that is going to be a negative, and also in the fourth quadrant, but it's the same number, 0.5, 0.5, and then negative 0.5. Then the same thing here, we know that cosine is negative in the second quadrant, it's also negative in the third quadrant. So we're going to say angles with equal ref have trigonometric ratios that are equal in magnitude ratios that are equal in magnitude. So for instance, if it's 0.5, all of them are going to be 0.5, but some of them are going to be negative. All right, let's look at some examples before we go to the next section. All right, in this example, we want to find the exact values of sine, cosine theta, and tangent theta, given that P on the terminal side of theta has the coordinates minus 3, 4 in the first one. So yeah, we always need to make a sketch. So for A, minus 3, 4 in the second quadrant, so our sketch is going to look something like this. So there is minus 3, 4, which means this is going to be minus 3, and that is going to be 4. What we're looking for is the length of the hypotenuse, r this side. Okay, so we'll start by finding that r squared is going to be negative 3 squared plus 4 squared, going to be 9 plus 16, going to be 25. So r is going to be plus or minus 5, but r is a length, so we are only going to choose 5, because this is our theta here, and then sine theta is just going to be the opposite over the hypotenuse. It's positive, it's in the second quadrant, so that's fine. Cosine theta is going to be negative 3 over 5. It's negative, it's in the second quadrant, so that's okay. Tangent theta is going to be negative 4 over 3. And then, so that is done. Question 2, both of the coordinates are negative, so that means we're going to have an angle in the third quadrant. Okay, so P is negative 2, negative root 5. So this is going to be negative 2. This is going to be negative root 5. This is r. That is our angle theta. So r squared is negative 2 squared plus negative root 5 squared. This is going to be 4 plus 5. It's going to be 9. So r is going to be 3. So if r is 3, it means sine theta is going to be negative 2 over 3. Cosine theta is going to be negative root 5 over 3. And tangent theta is going to be positive. It's going to be root 5 over 2. Okay. So we're going to give you a chance to work through these two. Just pause the video and have a go, and then you can continue. Right, at this point we're expecting that you've already had a go at these two here, so if you haven't, please do before we can show you our answers. So for C, 5 minus 12 is in quadrant 4, so the sketch is going to look something like this. Then Pythagoras shows that r is 13, so then sine is going to be minus 13, 12 over 13. cosine theta is going to be 5 over 13, and tangent theta is going to be minus 12 over 5. In D11 is in the first quadrant, so the sketch looks like this. The hypotenuse is going to be square root 2. So sine theta is going to be 1 over root 2. Cos theta is also 1 over root 2, and tangent is equal to 1. Okay, in this question, we're given one of the trigonometric ratios and a condition, and they want us to find the two others. So for instance, in number 2a, we have that sine theta is root 3 over 2, and cos theta is negative, or cos theta is less than 0. So we first need to decide in which quadrant this angle is. So the quadrant where sine is positive and cosine is negative, there's only one. It's the second quadrant. So that means the orientation of this angle is going to be a bit like this. Okay. Then sine theta is root 3 over 2. We know that sine is opposite over hypotenuse. So that means we can put root 3 here opposite and put 2 here. So all we need to find is this length, which is x. So this time Pythagoras is going to say x squared plus root 3 squared is equal to 2 squared. So x squared plus 3 is 4. So x squared is 1. So x is plus or minus 1. But since we're in the second quadrant, x has got to be negative 1. Okay, so we've got sine, so we just need to write the cosine and the tangent. So cosine is going to be minus half, and tangent is also going to be negative root 3. Okay, then in question B, we have that tangent theta is equal to 2 and sine theta is negative. So again, the only quadrant where tangent is positive while sine is negative is in the third quadrant. The two quadrants where tangent is positive, first quadrant and third quadrant. But in the first quadrant, sine is positive. Then tangent is opposite over adjacent, so it means opposite here is negative 2 because we're in the third quadrant, and that adjacent is negative 1. So we need to find r. R squared is going to be negative 1 squared plus negative 2 squared. So r squared is going to be 5. So r is going to be square root 5. Remember that r is always positive. So that means sine theta is going to be negative 2 over square root 5. And cosine theta is going to be negative 1 over square root 5. So those will be the two other trigonometric ratios. In part C, we have secant theta negative 7 over 2, and we're told that theta is in the second quadrant. So probably the first thing we need to do here is to write this in terms of cosine. Cosecant is the reciprocal of cosine. Then cosine is going to be negative 2 over 7. So we are in the second quadrant. So cosine is -2, and that is going to be 7. We need to find the y. So by Pythagoras again, y squared plus -2 squared is going to be 7. So y squared is going to be 49 minus 4. So y squared is going to be 45. So y is going to be plus or minus the square root of 45. 45 is 9 times 5. So it's going to be plus or minus 3 times root 5. But this is a distance going up. So we are going to, it's going to be the positive one. So we already have cosine. We write sine and tangent. So sine is going to be 3 root 5 over 7. Tangent theta is going to be 3 root 5 over -2. We're going to give you 2 to try. So in D, sine theta is -√7 over 2, while cosine theta is positive. So we're going to find cosine theta and tangent theta. And then in this case, tangent theta is -3, sine theta is positive. So just work on those two. And then when you continue the video, you can compare with our answers. Okay, just one typo here. This is supposed to be √7 over 3. So this is over 3 here. Sorry about that. Alright, so assuming that you've already had a go at these, here we go. So in D, sine is negative, cosine is positive, so we can only be in quadrant number 4. Sine is opposite over hypotenuse, so that is got to be the opposite hypotenuse. And then if we work out x, we find that x is square root 2. Then that means cosine is going to be actually square root 2 over 3, and tangent is going to be negative square root 7 over square root 2. In E, tangent is negative, but sine is positive. So that can only happen in quadrant number 2. So tangent is -3, is opposite of adjacent, but the opposite must be positive because it's going up, so the negative is going to be there. Then we find that the hypotenuse is √10, and then the sine and the cosine will be given by those two.